Hi, let's talk about diprotic and polyprotic acids and bases. So diprotic acids and bases are capable of donating 2 protons. Polyprotic, poly, it means many. So you could have triprotic or polyprotic. The quantitative analysis course that we're in, according to Dr. Butcher, does not really cover polyprotic species. We just stick to the diprotic for calculations wise. So he'll probably talk about it, but he's not going to make us do any calculations on it. So we're going to talk about diprotic acids and their conjugate bases right now. Okay, and there is a very specific relationship that we're going to talk about with the diprotic acids, their Ka values, and the Kb values of their conjugate bases. So I have an example up here on the board, and this is chromic acid, H2CR, chromic O4, all right? And so when you put that in water, it is going to dissociate some. It is a weak acid, so it will not fully dissociate, but it will dissociate some into HCrO4 minus and H plus. All right, and this is going to give us our Ka1 value, or our K1 value. That's what it's going to be referred to as, just our K1. Then it will continue to dissociate in water, okay? So then you've got your HCrO4 minus is going to dissociate into CrO4 minus 2 and H plus. This is going to be our K2 value. Now, the thing that we need to realize and think about when we're doing the calculations for Dr. Butcher is that your K1 value, your Ka1 value, when you pair it up to try to figure it out with Kw, what you're going to use as the offset there for Ka1 is Kb2. And for Ka2, you're going to use Kb1. And the reason for this is that we have to match up our species in the reactions in order to be able to put the numbers in order and together. So in our first reaction here, we've got H2CrO4, and then it's going to dissociate it into HCrO4 minus. Now let's look at our Kb values. Our first one here, we start with CrO4 minus 2 and then go to HCrO4. Well, we don't have H2CrO4 here. We don't have chromic acid in this first one, okay, because we're adding on 1 proton at a time. Just like we took them off at one at a time, we got to add them back one at a time. So that means that we're going to go down to Kb2 here, okay, because this starts with HCrO4 minus. You add that to water, and then that gives you your chromic acid back and a hydroxide ion for Kb2. So when you're doing your calculations, like if you have Kb2 and he's wanting you to do a calculation with the acid there, you're going to take your Kb2 value, all right, and you're going to figure out your Ka1 or your K1 value on that, and vice versa. If you have K1 and you need to find K2, or if you have K2 and you need to find Kb1, then you're going to do the conversion with the Kw value. All right, now I'm going to stop the video here, and then we're going to work out some examples, and I'll get that posted for you. All right, I did want to talk just a little bit more about the acidic and the basic forms of these polyprotic acids and bases. Okay, so we know that especially with weak acids like chromic acid, which we talked about before, they don't dissociate a lot. Like their Ka values, how much they dissociate, is very small amount. So when we're doing calculations, a lot of these calculations, we're going to assume that that Ka1 value is just going to equal K1, because we're assuming, and it's a good assumption, that our second step of dissociation does not affect our calculations that much, because it is very, very small. It is not 0, but it is very, very small, and it's not generally large enough to affect our calculations. I have not looked ahead enough in the quizzes to see if he's going to make us do any quadratic formulas to just solve for anything yet in these, but I will look into that and then make a video of it if we need to do that. And it's the same thing with the bases. When you're reacting a salt of the acid, so the conjugate base, with water. That's a hydrolysis reaction is what it is. That first step, when you're adding that first proton, that's going to be your biggest step. Okay, and then the second one is going to be much, much smaller. All right, and then you're going to have this wonderful middle area, which is your intermediate area. And that's probably where a lot of our calculations are going to be based, is he's going to have us do calculations with that intermediate step there. I did look at a couple of the quizzes, and they did have calculations on that. And there is a formula that I will show you guys here in just a minute, and we'll talk about it.